Good afternoon. Let's talk a minute about life cycle analysis in the 4 phases. Typically, I want to come at this in two different ways. From my standpoint as an economist and being trained to think as an economist, the role of an economist, most importantly, is to provide an objective viewpoint. That is, you don't want to bring any of your beliefs or values into it. You simply want to go with what the data says. That's a little difficult sometimes with life cycle analysis, because the way you approach the problem is going to have some effect of your own upbringing, of your own beliefs and value systems on how you approach that. You have to be very careful about how you quantify that. So number one, for an economist, or in terms of doing a life cycle analysis, is to know what the objectives of the study are. There's lots of different ways of doing the LCA. Do you want to identify leakages? Are you interested in identifying the overall system to determine what those leakages are? What are you really trying to do with respect to that? And when I say that, probably the most important aspect of that would be to identify what bounds you're going to do this study within. So let's just take bioenergy for a moment and say we're going to do a life cycle analysis. So as we talked about last time on the lecture I gave on ecosystems, you know, bioenergy is one part of this huge ecological system. Now you could break it down and say, I only want to look at the impact of the substrate that goes into making the biofuels and the products that come out of there, and not have anything to do with carbon sequestration that comes from that, or how that feeds back, or the effect of global warming on all these. It just could grow. So what you want to do first is come up with those objectives and come up with those bounds on how you're going to frame that, because it could be a very large or very small problem depending on how you want to define it. The second thing is and I'll give you 3 words that I kind of use, is alternatives, possibilities, inventories. All right. So again, what all are you going to encompass within those objectives? How deeply are you going to go? Are you going to go? Are you going to trace everything right back from the cradle to the grave with respect to all the things that are in that cycle of nutrients? So you would start from the ore itself. If you're mining an ore and you're going to turn that into steel, and then that steel goes into a house, and then you're going to reclaim it, and where does it go? Does it go to a dump? Does it get put back into something? And then all the products that stem from that, all the externalities, everything. So that's a very large picture again, and what you want to do is think about, how do I pull those bounds down, and what inventories am I going to want to take? What are my alternatives? And then the next one is, once you've done that, is this process that you're looking at, whether it's biofuels or construction of a house, whatever it is, what are the impacts? Now you want to measure. I've set my objective. I've got my bounds. What are the impacts? What are the measures? What are the leakages? What's happening to those to that resource flow? So that would be the next thing. What are the consequences? What are the impacts? So now, once you've finished and you've got an objective, and hopefully the analysis that you did it reflects that objective, you've bounded it so that you're not continuing to roll out and capture everything that there is on the globe. You've got a very doable project. You've identified what the leakages are, what the consequences, what the impacts of that process that you're looking at is within those bounds. Now the most critical point, as I said from the beginning, is to keep a very objective viewpoint. And what do those results mean? What are the implications of that? What's the interpretation of those results? And using words like good and bad aren't really real great for interpretation of the results. What you want to do is identify, measure. So you can talk about, for instance, that ore we were talking about. You lost 30% of that process is never going to be reused again, and that gives you a pretty good idea of what's going on with the flow of that stock resource. Okay, so we'll be, as we move through the course, we'll be actually doing an LCA, and you'll have a chance to see what I'm talking about through the application.